Alright, so here what we have is 7 over 7 to the 1/3, and what we're showing is that 7 is really 7 to the first. So you really have 7, oof, that's ugly 7, I don't know why I wrote a Z, 7 to the 1 minus 1/3. Well, that's the same thing as 7 to the 3/3 minus 1/3, because 1 is 3/3 when you create common denominators. So you end up with 7 to the 2/3. Alright? There you go. Next we have 12 to the 1/3 over 4 to the 1/3. So here's what we can do. We can rewrite this where 12 over 4 are inside parentheses and 1/3 out on the top. That's 1/3. And that's still raised to the second, because what's happened is they've written it where the exponent has already been distributed to the fraction. So you can go in reverse and sort of factor out almost the exponent, even though you're not technically factoring. Okay? Then 12 over 4 equals 3 to the 1/3, all raised to the 2/3. Or excuse me, raised to the 2. I'm getting ahead of myself here. All raised to the 2, which equals 3 to the 2/3. Okay? And that's simplified as far as we can go. Alright. Here are a list of properties. Number 1 simply says properties of rational exponents. When you have same bases, you add the exponents. And then there's an example using rationals. Nothing different than our properties of regular exponents, except I'm just showing you how they work when there's fractions as an exponent. Here we got a base raised to an exponent, and all that's raised to another exponent. And so you multiply the exponents. Examples there, examples all the way through. Okay? All this has been seen before. We're just giving you an example now that shows fractions. So please go ahead and take some time to write all those down. Make sure you commit them to memory, and if you have any questions, let me know. Okay, so here we're going to use properties of radicals. And what we have is one of the properties of radicals is if you have the same index, like we do here, 3 and 3, what you can do is you can multiply the interior, the arguments, underneath one large radical. So I can say third root of 4 times 16, that's a 1 by the way, which equals the third root of 64, which is 4. Alright, and again over here, we can put the entire fraction underneath the root. We have the fourth root of 162 over 2, which equals the fourth root of 81, which equals 3. Now the key to these ones realistically is kind of getting a feel for where you think this is headed. You've got two things up here that are associated with 4. So I'm guessing that at some point it's going to be 4 towards the end somehow. I kind of have this sort of feeling going on in the end anyways. But I also know my rules. I know that if I have two radicals multiplied together with the same index, I can multiply the interiors and then try to simplify from there. Same thing with fractions. I can distribute radicals to fractions, so I can undistribute radicals to fractions just like we did here. Alright?